Tonight, as you lie in the dark, your room dissolves. The ceiling fades first, then the walls. Then gravity loosens its grip, just slightly enough for your mind to drift. You are floating, not above your bed, above Earth, above the Milky Way, above 200 billion galaxies suspended like embers in an ocean of black. And then a question finds you. If the universe goes on forever, does it have an edge? It sounds impossible. Infinite means no boundary. An edge means a limit. The two cancel each other out. And yet, modern cosmology suggests something stranger. The universe could be infinite and still be curved in such a way that if you traveled far enough, you might end up back where you started. No wall, no cliff, no glowing cosmic barrier, just geometry. Tonight, we're not just asking whether space ends. We're asking something more unsettling. What does it mean for something to have no outside? And if there is no outside, where are you exactly? Stay still. Let your breathing slow. We're going to the edge of everything. Imagine an ant walking on the surface of a perfectly smooth balloon. The ant believes it is walking in a straight line. From its perspective, the ground stretches endlessly ahead. There is no edge, no border, no drop-off. But zoom out. You see the truth instantly. The ant is not walking on an infinite plane. It is walking on a curved surface finite in area, yet without an edge. If it keeps going long enough, it will return to the exact point it started from. No. Wall stopped it. Geometry did. This is not science fiction. This is the language of general relativity, the theory proposed by Albert Einstein in 1915, where gravity is not a force pulling objects together, but the curvature of space-time itself. Mass bends space, energy bends time, and the universe, on its largest scale, may not be flat at all. When astronomers measure the cosmic microwave background, the faint afterglow of the Big Bang, they are not just studying ancient light. They are measuring the shape of reality. Instruments aboard the NASA spacecraft WMAP and later Planck map temperature fluctuations across the entire sky with extraordinary precision. Those tiny variations, differences of 1 part in 100,000, whisper something profound. The universe appears astonishingly flat, not curved like a sphere, not saddle-shaped like a Pringle, flat. But here is the tension. Flat does not automatically mean infinite. A sheet of paper is flat, but it has edges. So what makes cosmic flatness different? The answer lies in scale. If the observable universe, the region from which light has had time to reach us since the Big Bang, is only a tiny patch of something far larger, then even a curved universe could appear flat within our limited horizon. You are looking through a keyhole at an ocean. From your narrow view, the water seems perfectly level. You cannot see the curvature of the Earth beneath it. The observable universe spans about 93 billion light-years across, but that is not the size of the universe. It is merely the size of what we can see, and this is where effort enters the story. For centuries, humans have strained against the dark, trying to answer a question that may not even be testable. In ancient Greece, philosophers like Aristotle imagined a finite cosmos enclosed by crystalline spheres. Later, Giordano Bruno dared to propose an infinite universe filled with countless suns, a radical idea that cost him his life. In the 20th century, Einstein himself initially believed in a static, finite universe. When equations suggested expansion, he inserted a cosmological constant to keep the cosmos still. He later called it his greatest mistake, but perhaps it was not a mistake, only a reflection of how deeply our minds resist infinity. Because infinity is not just large, it is unbounded, and unboundedness feels like falling. Tonight, as you drift toward sleep, imagine accelerating in a straight line through space. You pass stars. Nebulae glow like stained glass. Galaxies swirl silently. Millions of years slip by. You never hit a wall. You never see a sign that says, end. Does that mean there is no edge, or does it mean you cannot reach it? Now the scale shifts. Imagine instead that space is curved in a higher dimension we cannot perceive. Just as the ant cannot conceive of above the balloon, we may be confined to a three-dimensional surface embedded in something deeper. In this model, the universe could be finite in volume yet have no boundary, like the balloon, except infinitely more complex. You might travel forever without encountering an edge, not because the universe is infinite, but because edges require an outside. And what if there is no outside? Pause on that. No outside. When you close your eyes tonight, your room has walls. The planet has an atmosphere. The galaxy has a halo. But the universe by definition includes everything. If there were something outside it, that too would be part of the universe. The word collapses into itself, and suddenly the question changes. We are no longer asking, does the universe have an edge? We are asking, does the concept of edge even apply? The ant's limitation is dimensional. Ours may be conceptual. Modern inflation theory proposed by physicists like Alan Guth suggests that in the first fraction of a second after the Big Bang, space expanded exponentially, stretching tiny quantum fluctuations into cosmic scales. Inflation may have smoothed out any initial curvature so thoroughly that the universe appears flat regardless of its true global shape, which means the observable universe could be a tiny wrinkle on an unimaginably vast structure, possibly infinite, possibly closed, possibly something else entirely. Here is where human effort becomes almost heroic. Scientists build detectors in Antarctica to measure microwave radiation from 13.8 billion years ago. They suspend instruments in space to escape atmospheric distortion. They refine equations. Across decades, challenging each other, correcting errors, pushing deeper into abstraction, all to answer a question that cannot be touched, cannot be reached, cannot be seen directly. This is not passive curiosity. It is intellectual endurance. It is the refusal to accept ignorance as final. And yet, even with all this effort, we may be limited by a cosmic horizon, a boundary beyond which light has not had time to reach us. There may be regions forever hidden, forever inaccessible, not because they are far away, but because space-time itself is expanding faster than light can cross it. So you lie there tonight, breathing slowly, realizing something unsettling. Even if the universe has an edge, you may never know. And that ignorance is not a failure of technology. It is written into the structure of reality. But this is only the beginning, because the deeper we push into geometry, quantum mechanics, and topology, the stranger the possibilities become. What if space folds? What if infinity repeats? What if you somewhere unimaginably far away already exist again? To understand that, we have to leave geometry behind and step into something even more unsettling. The topology of existence itself, continuation available in the next installment. Your breathing is slower now. The body is still, but the mind keeps moving, because geometry was only the doorway. What waits beyond it is not shape but connection. At first, topology sounds harmless, a quiet branch of mathematics, no stars, no galaxies, no drama, just rules about what can stretch, twist, or fold without tearing. But topology does not care how something looks. It cares what remains the same when everything else changes. A coffee mug and a donut are identical in topology. One whole, that's all that matters. And suddenly this innocent idea becomes dangerous, because if topology applies to space itself, then the universe may not only curve, it may connect back onto itself in ways your intuition was never built to survive. Picture this. You drift forward through space endlessly. No wall, no edge, no signal that anything has changed. Yet unknown to you, the path ahead is slowly bending not downward, not sideways, but through dimensions your senses cannot access. Eventually, impossibly, you see something familiar, a galaxy, then another, then a blue star system you recognize, and finally, Earth, not another Earth, the same one. You have not reached the edge of the universe. You have looped around it. This is not fantasy. This is a legitimate solution to Einstein's equations, a multiply-connected universe, finite, edgeless, repeating, like a hall of mirrors, except the mirrors are reality itself. Cosmologists have searched for evidence of this. They look for matching circles in the cosmic microwave background, identical temperature patterns appearing in opposite directions of the sky. If space wraps around itself, light from the same ancient event could reach us along different paths, two copies of the same echo. So far, the data is silent, no confirmed repeats. But silence is not proof of absence. It may only mean the universe is larger than our observational reach. And this is where human effort begins to feel painfully small. We are ants measuring the curvature of a balloon with rulers made of starlight. Now let the scale shift again. Smaller, much smaller, down to the quantum level. At distances trillions of times smaller than an atom, space itself may not be smooth at all. It may be grainy, foamy, flickering. According to quantum gravity theories, space-time could be stitched together from discrete units, loops, strings, or networks of relations. In some models, space is not fundamental. It emerges, like temperature emerges from the motion of molecules, or like waves emerge from countless water particles moving together. If space emerges, then asking whether it has an edge may be like asking where the edge of a wave is. The question breaks. This is where physics and philosophy collide. If the universe is infinite, does it contain every possible arrangement of matter, every possible version of you, a version where you chose differently, a version where this sentence was never spoken? In an infinite cosmos governed by probability, repetition is not unlikely. It is inevitable. Somewhere, unimaginably far away, the same atoms could assemble into the same thoughts, the same doubts, the same moment of listening. You, again. This idea is terrifying not because it is mystical, but because it is mathematically mundane. Infinity does not care about uniqueness. But maybe the universe protects us from this conclusion. Maybe it is finite after all. Closed, limited, wrapped, a cosmic refusal of endless repetition. Yet even then, no edge appears, no cliff, no cosmic signpost saying beyond this point, nothing exists. Because an edge would require an outside, and the universe has nowhere to place it. Now feel the effort again. Human effort. The kind that does not lift stones or build walls, but builds understanding where none existed. Equations scratched across decades. Telescopes launched knowing they may never answer the question they were designed for. Careers devoted to measurements that reduce uncertainty by a fraction of a percent. Not for comfort, but for truth. And sometimes the truth is restraint. Modern cosmology may never know whether the universe is infinite, because the observable universe is bounded not by space but by time. Light has a speed. The universe has an age. And beyond that horizon, knowledge dissolves, not because we are weak, but because causality itself draws a line. This is the quiet tragedy and triumph of science. We push until the universe says no more, not with violence, but with silence. And yet, even the silence speaks. It tells us something profound about our place. We are not meant to stand outside the universe and observe it whole. We are embedded within it, made of it, thinking with it. The question, does the universe have an edge, may be flawed not because it is foolish, but because it assumes we are separate from the thing we are asking about. As sleep deepens, let one last image form, not of space expanding, but of understanding. Human understanding stretching generation by generation across centuries, never reaching the end, never touching the boundary, but always moving closer. And that movement itself, that relentless effort to know, may be the closest thing to an edge we will ever find, because beyond it waits something even stranger. Not geometry, not topology, but meaning, and that is where we go next. The room is completely quiet now. Your breathing is steady. Your body has surrendered to gravity, but your mind is standing at the edge of something that has no edge. We've stretched space. We've curved it. We've folded it. We've looped it back onto itself. And still the question lingers in the dark. If the universe has no boundary, what does that mean for you? Let's slow this down. Forget galaxies for a moment. Forget infinity. Imagine a book. Every page contains a complete story. Each character lives, struggles, loves, suffers entirely unaware that the page has borders. From their perspective, reality is continuous. But from yours, you see the edges instantly, the margin, the binding, the cover. Now ask yourself something unsettling. What if we are the characters on the page, not trapped in space, but embedded within a deeper structure we cannot perceive, not because it is far away, but because it is orthogonal to our experience, a direction we cannot turn? In modern theoretical physics, some models propose that our universe could be a brain floating inside a higher dimensional space. The mathematics emerges from string theory and higher dimensional gravity. To us, the universe feels complete, but it may be a slice of something larger. If that larger structure exists, it would not be outside in the ordinary sense. It would be beyond the geometry our brains evolved to interpret. Just as a two-dimensional being cannot imagine up, we cannot imagine the direction in which the universe might bend. And here, the paradox deepens. Because if the universe has an edge in a higher dimension, it would not feel like an edge from within. No cliff, no glowing border, just an unreachable limit encoded into the fabric of spacetime. Now, shift again. Imagine that the universe is truly infinite. No wrapping, no closure, no curvature returning you home, just endless expansion. In such a cosmos, the laws of probability become unavoidable. In infinite space with finite possible particle arrangements in any region, patterns must repeat. This is not poetry, it is combinatorics. If you shuffle a deck of cards enough times, eventually the order repeats. In an infinite universe, there are only so many ways atoms can arrange within a finite volume. Eventually, somewhere, the same arrangement must occur. Again, a duplicate Earth, a duplicate Milky Way, a duplicate you, not metaphorically, physically, breathing, wondering about infinity. And here is where the psychological weight settles in. If copies of you exist infinitely many times, what becomes of uniqueness? What becomes of meaning? Does effort matter if it has happened before and will happen again endlessly? This is where science touches philosophy with cold fingers. Because infinity is not emotionally neutral, it destabilizes significance. But pause, take a breath, because this is where we must be careful. Physics describes structure. It does not assign value. The existence of repetition does not erase experience. Even if another version of you exists beyond 10-10-29 meters, that does not dilute the immediacy of this moment. Pain still hurts. Joy still floods your chest. Effort still burns in your muscles. Meaning is local, and locality may be the most profound limitation of all. Human effort, across history, has been an attempt to transcend locality, to see beyond the horizon, to know what lies past the cosmic veil. From Edwin Hubble discovering that galaxies are racing away from us, to the detection of gravitational waves predicted by Albert Einstein a century earlier, to space telescopes measuring distortions in ancient light, every generation pushes against a boundary, not a physical wall, but an epistemic one, a limit of knowability. And every time we reach it, we discover something humbling. The universe is not obligated to be fully accessible. There may be questions whose answers are not hidden, but undefined. Now consider the observable horizon again, because this is the most honest edge we have, the boundary beyond which light has not had time to reach us since the Big Bang. It is not an edge of space, it is an edge of information. Beyond it, galaxies exist, perhaps infinitely many, but they are causally disconnected. Their light will never arrive, not because it cannot travel fast enough, but because space between us expands too quickly. In a universe accelerating under dark energy, distant galaxies will eventually slip beyond our horizon forever. In the far future, observers in our galaxy may look out and see nothing but darkness. They will conclude they live in an isolated cosmos. They will be wrong, but they will have no evidence to prove it. And that realization should make you feel something sharp. Knowledge itself has a cosmic deadline. There are truths that can only be discovered within certain windows of time. We happen to exist in one. Now return to the original paradox. Can the universe be infinite and still have an edge? The answer is both simpler and stranger than expected. If infinite, it has no edge but may still contain horizons that function like edges to observers. If finite and curved, it may have no boundary at all, yet still possess a total volume. Edge and infinity are not opposites. They are concepts that depend on perspective. On dimensionality, on the rules of geometry we inhabit, and those rules may not be ultimate. As sleep approaches fully, let one final image settle. Imagine standing in absolute darkness. You strike a match. The flame flickers, illuminating only a small circle around you. Beyond that circle, reality continues, but you cannot see it. The darkness is not empty. It is simply beyond your light. Human knowledge is that flame. The observable universe is the circle. The rest, finite or infinite, remains unlit. But here is the quiet revelation. The absence of an edge does not mean the absence of mystery. In fact, it guarantees it. Because if there is no boundary to reality, there is no boundary to discovery. And if there are limits, they are not walls. They are invitations. You are not separate from this universe. You are a localized expression of it, matter arranged into awareness, asking questions about its own extent. The universe wondering whether it ends. And perhaps that is the final inversion. Maybe the universe does not need an edge, because its boundary is wherever consciousness stops asking. And tonight, as you drift into sleep, the question remains open, not resolved, not closed, suspended like a star beyond the horizon. Infinite, perhaps. Edgeless, perhaps. But undeniably vast enough to hold your curiosity without ever exhausting it. The night is deeper now. Outside, the world is silent. Inside, your mind is hovering over something that refuses to close. We have asked whether the universe has an edge, We have stretched geometry until it bent. We have let infinity multiply you into endless copies. But now we arrive at something more intimate, not the edge of space, the edge of understanding. There is a quiet assumption hidden inside every question about the universe, that it is a thing, an object, a container, something out there with measurable property size, curvature, boundaries. But what if that assumption is the first illusion? In quantum physics, reality does not behave like a solid stage on which events unfold. At the smallest scales, what we call space may be nothing more than relationships between events. Some approaches to quantum gravity suggest that spacetime is not fundamental. It emerges from deeper, non-spatial processes. In certain formulations, geometry appears as a byproduct of entanglement, not a background, a consequence. If that is true, then asking whether the universe has an edge might be like asking where the edge of a conversation is. Where does a dialogue end? At the last word? At the silence after? Or does it persist in memory, reshaping thought long after the sound fades? Perhaps the universe is less like a box and more like a process. Now feel the shift. Instead of imagining space as something you move through, imagine it as something that updates, moment by moment, like frames in a cosmic computation. Some physicists have proposed that reality may operate on informational principles, that at its deepest level, the universe is not made of particles or fields, but bits, binary distinctions, yes/no, here/not here, connected/not connected. In this view, space is a network, a vast relational web. Edges in such a system are not spatial borders. They are limits of connectivity, boundaries of interaction, and those limits may be fluid, context-dependent, even observer-dependent. Consider this carefully. Your observable universe is defined not by distance alone, but by causal contact. If something can influence you even indirectly, it belongs to your cosmic domain. If it never can, it may as well not exist for you. Edge becomes relational, not absolute. The boundary of your universe is the boundary of your influence, and that boundary expands and contracts depending on energy, motion, and time. This is not mystical. It is encoded into relativity itself. Now let's widen the frame one last time. Imagine the entire cosmic story compressed into a single timeline. 13.8 billion years ago, a hot, dense beginning, rapid expansion, cooling, atoms forming, stars igniting, galaxies assembling, planets condensing from dust. On one such planet, molecules begin replicating. Life emerges. Evolution experiments for billions of years. And eventually, neural networks complex enough to reflect on existence appear. The universe did not grow an edge. It grew awareness. For the first time, matter began to ask where it ends. This may be the most astonishing development of all. Not cosmic inflation, not dark energy, but cognition. Human effort across millennia has been an attempt to extend that awareness outward. Stone circles aligned with stars, bronze instruments tracking planetary motion, mathematics refined through generations, telescopes lifted above atmosphere, detectors cooled near absolute zero to catch whispers from the early universe. Every experiment is an act of defiance against ignorance. Every equation is a bridge thrown into darkness, and yet with every answer the horizon retreats. The more precisely we measure curvature, the more precisely we discover uncertainty. The more tightly we constrain infinity, the more creatively it evades us. This is not failure. It is structure. Here is the quiet shock. It may be impossible for any being embedded within the universe to determine its total structure, not because we lack intelligence, but because totality cannot be observed from inside. A character inside a novel cannot read the final page without being written there. We are bound by perspective, bound by causality, bound by dimensional access. And perhaps that is what an edge truly is, not a wall in space, but a limit in perspective. So can the universe be infinite and still have an edge? Yes. If by edge you mean a horizon, a limit of observation, yes. If by infinite you mean unbounded in extent, yes. If by edge you mean conceptual boundary, the point where language collapses, because infinity is not something we experience directly. It is something we approximate, something we approach asymptotically, like dividing by 2 forever without reaching 0. Now, as your consciousness drifts toward sleep, imagine the universe without edges, without outside, without final answers, not as something cold, but as something open. The absence of an edge means there is no final barrier to exploration, no ultimate ceiling to understanding, only expanding context. The paradox that once felt destabilizing now feels spacious. Infinity does not erase meaning. It enlarges the arena in which meaning unfolds. And an edge, if it exists, is not a cliff waiting to end the story. It is the place where curiosity meets mystery, where knowledge hands the torch to wonder. The lights of distant galaxies continue traveling. Some will never reach us, some already have. Some are just now arriving, carrying information billions of years old. And somewhere beyond every horizon, whether finite or infinite, reality continues, not waiting for us, not dependent on us, but somehow including us. You are not standing at the edge of the universe. You are part of its interior unfolding, a temporary configuration of atoms contemplating the structure that made them possible, the universe asking whether it ends. And perhaps the deepest truth is this: the edge is not a location, it is a question. And as long as that question survives in minds like yours, the universe remains, in a profound sense, without boundary. Now rest. Infinity does not need to be solved tonight. It only needs to be felt.